Sine of x is plus or minus, I'm going to leave it as 1 over root 2. The reason why I'm leaving it as 1 over root 2, because the next step would then allow for me to write it as root 2 over 2. Are we okay with that? But by doing it this way, I'm leaving it in my unrationalized state. That way I can say, hey, bozo, what angle has the opposite of 1 and the hypotenuse of root 2? Your pi over 4. Now this being plus minus, that means it's going to occur in all 4 quadrants. Pi over 4, 3 pi over 4, 5 pi over 4, and 7 pi over 4. Welcome back. What's that? Okay, and that's how it goes. Yes, yes, we should, because they're great. Oh yeah, there's extra credit on Friday. There's a pi down. Memorize pi.
Can you figure out how you're grading it?
You already figured out how you're grading it, right?
This I need to get. All right, so let's add to this. Let's talk about what's called general solutions. This is still 14.4, yes. We'll be in 14.4. That's 14.4 is where we're going to stop before spring break. So we'll just be in this for the next few days. I'll have something put together for you guys come Wednesday as far as some review stuff we'll do in class and go from there. Those of you guys that have been gone, just give me I'll get stuff from you in a little bit. Don't worry. Okay. So what we've done so far, guys, is we've done solutions of x within one revolution. We were just listing out all of our possible answers within one revolution. What we're going to do now is try to see if we can write stuff out more, I hate to use the word general, but more basic. Is there some way that we can just write out a statement that'll encompass every single one of our answers as well as all other possible coterminal angles as well? That's what general solutions mean. All right. Nice work, Lieutenant Lamo. Add 4 divided by 3. Are we okay with that?
Sure.
Secant squared x, 4/3. Now what do?
You square root it.
I take the square root. What happens when you take the square root over an equal sign?
Plus or minus.
Plus or minus. So we get secant of x is plus or minus square root of 4.
2.
I get 2 over root 3. Okay? I'm not rationalizing anything. I'm not bothering with any of that because remember, by leaving it in an unrationalized state, it's going to be easier to see where things are going.
Wait, so that's secant, so that's the opposite code?
Right.
Cosine?
So I move it over.
Is there a secant button in our calculator?
It's inverse cosine, but we don't worry about it. We actually don't do any calculator work with the inverse trig functions.
Okay.
Ever. I think you might do something in pre-calc, but other than that, you don't have to worry about it in alpha 2 at all. Okay. So in here, remember, secant is the inverse of cosine. If cosine was adjacent over hypotenuse, that means secant is hypotenuse over adjacent. Come on, guys. Enough with the pencil thing. So you've got your hypotenuse of 2 and adjacent of root 3. Which angle has the adjacent of root 3 and a hypotenuse of 2? Yes, ma'am. 30, yeah. We know.
So if would right, what we have the secant, the opposite secant still be cosine, so we basically just
Yeah, we're just working backwards from it. That's all. So we know it's going to be a pi over 6. Okay? Yes, ma'am.
Would secant, would that equal the cosine inverse of root 3 over 2?
Yes.
Okay.
Okay. So this is going to be my pi over 6. Now, what happens is, every other angle in the circle that has a reference angle of pi over 6 is going to work because it's plus minus, because it occurs then in all 4 quadrants. You have 2 quadrants that's secant's positive and 2 quadrants that it's negative. So what we do is, to start, when I start looking at what are called general solutions, I will list out, like we did the other day, just list out all of my reference angles. Those 4 angles on one revolution, they would have the secant value of plus or minus 2 over root 3. Rationalize it to root 3 over 3, whatever. Now, I need to figure out, is there some pattern that's thrown in between those 4 solutions? If you look at the values that are there, they're going up by 4/6, right? Now, if I go from here to here, how much do I go up?
6.
A pi, right?
Yeah, 1 pi.
If I go from here to here, I go up how much? 1 pi. So what happens is, if I start at pi over 6 for this example, to get to here is how far?
1 pi.
To get back to it is how far?
1 pi. 1 pi. 1 pi.
And so it oscillates.
So it's just a forever continuous thing.
Correct.
So there's infinite answers.
Correct. That's what general solutions mean.
So
What are
we just-
all the angles that you can come up with that will still have this, that it basically you're listing out all the coterminal angles.
So are we going to actually have to list out for infinity? Or like
No.
just write those 4?
Here's what you do. It's pi over 6 plus, well, how often did you go between pi over 6 and 7 pi over 6? Every how many revolutions?
Plus pi.
Plus pi times the number of revolutions that you make. So if I go 7 times, I start here and I go 7 pi, I'll go 1, little 2, little 3, little pi's, 4, little 5, little 6, little pi's, 7, and I still have the same secant value. If I do 9, 1 little, and so on and so on, you're still going to wind up on one of those 2 angles, and it'll still have the same answer.
So like for all the homework tonight, we just start with that first angle and then add pi plus n, or pi times n.
Maybe,
Wait, what?
because it's not always a,
1
the,
pi.
it's not exactly. It can be different, it might occur, it might not occur, depending upon the problem. Each problem has its own general solution. And then I do this again with the 5 pi to 11 pi. The other answer would be 5 pi over 6 plus pi n. And that's how I can oscillate between those 2. So my general solution then just has 2 answers.
Wait,
Yes, Ian?
is it always going to be like pi over 6 or whatever you use plus pi?
Like I just said, no. Each problem is different.
Pi over 3.
You could have, you guys are very, very accustomed to assuming, to assuming that the first time you see something, it's going to happen the same way every time. It's not like that. Every one of these problems, you have to draw it out so that way you can see what differences there are. Sometimes you have plus or minus answers. Sometimes you don't. Sometimes you only have one solution that it goes, and it just depends upon the problem. Yes, ma'am.
So why would we just leave this pi over 6 plus pi n? Why do we have 5 pi over 6 plus?
Because there was 2 different angles that would go through it. The pi over 6's took care of the positive answers. The 5 pi over 6 took care of the negatives. Guys,
Oh,
please.
I see now.
The same thing they did over the weekend if we had a plus or minus.
Pretty much. But you're just not listing out them all. You're putting it in terms of a general idea.
Oh.
Okay. Kind of.
We'll compress it.
Okay. Let's do the same thing. Let's try the same thing. So I have tangent squared of x. Oh, real fast, just I'm going to apologize. I have a bad habit of not saying the x value. I might just say tangent squared equals cosine tangent squared. I might not throw in that value of x. You don't need to worry about anything in algebra 2 about that value of x ever changing. It's all, for any of this stuff to work, it's going to be the same variable. Okay? When we get into a lot of this identity stuff later on after spring break, I probably won't write down the x value ever, just because it takes too much time and it gets messy. All right, but with equations, I might not say it, but it's still there. Okay? Yes, ma'am.
So, do you do this anytime it's like something squared,
No.
or is it only when it asks
Yes.
specifically?
It'll say find the general solution, or it'll say find between 0 and 2 pi. If it's 0 and 2 pi, it's what you did. General solutions are going to have an n in it because there's an n in the word general. Don't shake your head in disgust. That's how you're going to remember it. Yes, ma'am.
So not all problems that have like some square in it are going to be general solutions. But
I
all
just answered that.
But all general solutions will be the square.
No.
No.
It's going to be in the instructions.
Like, if it's in the instructions, does that mean automatically one will have a square?
No.
Okay.
It could be sine of x equals 1. Find the general solution. All right, it doesn't have, you can't pigeonhole anything. It's just an instruction, okay? Everything changes. Set aside equal to 0. So what are you going to move? Might as well move the other one over, right? If I do this, I can go, excuse me. Let's see, then we get 1. Oh, wait, did I not want to do this one? Bless you. No, this will work. Tangent squared x minus cosine times tangent squared x. What do those two things have in common? Tangent squared. Since they have tangent squared in common, what I'm going to do is factor out a tangent squared. Think of it as GCF. And I have that. Everybody okay with that? Do I have two terms then I can set equal to 0? Yeah. I have two terms now that I can set equal to 0. I can say tangent squared x is 0, and 1 minus cosine of x is 0. What's the square root of 0? 0. Do I have to worry about plus minus? Nope. So that means this, the tangent portion is what angle has a tangent value equal to 0. Now, tangent, if you recall, is y over x, which means that your x value had to be 1, your y value is 0. Where is x 1 and y 0? On the quadrantals, good. So you have tangent of 0 is going to be at 0 or at pi. Are we okay with that? I'll come back to the general solution for this here in a second. I'm just going to solve the. I'm just going to go ahead and solve the other one first. What do you do with the other one?
You add cosine of x to the other side, then inverse it so that x equals the cosine inverse of x.
Good. So you get 1 equals the cosine of x. So what angle has the cosine of 1? Correct. Well, wait, hold on. 45, no. You're thinking tangent, sorry. Because I just wrote down tangent. Cosine, where is cosine going to be equal to 1? Remember, cosine is your x. Where is x equal to 1? At 0. Got to be at 0. Because at negative 1, at pi, it's negative 1. So this answer would be at x equal to, well, I'm sorry, I wrote this wrong. It'd have to equal 0. Okay? So in terms of general solution, how long does it take me to get from 0 to pi? How long does it take me to get from pi back to 0? Pi. So does that difference ever change? No. So my answer then, since this is already part of this, my answer is going to be 0 plus pi n. Bless you. What's that?
So you take whatever the smallest first value is?
That's generally what, that's usually what people do. Okay, that's usually what people do. You're not wrong if you start at pi, and then, but the thing is that you'd have to, how do you accommodate for that 0? You know what I mean? So by starting at the base and working your way up, it kind of starts you out. Because if you think about that's going to be like your first reference angle. It would be at 0 and just as it comes back around. Yes, ma'am.
So for the cosine part, the 0 would that
I don't have to worry about that. You're right. It would be if this wasn't here, this would be 0 plus 2 pi n. Very good. But since this 0 is already part of this one, it's okay. All right, it works out well. All right.
So how much harder does it get?
Let's get the one I wanted to show you guys with the funky. Ah, here it is. Oh, that's not it. Oh, sorry, that's cotangent to the fourth. Two cotangent to the fourth x minus cotangent squared of x minus 15 is 0.
I think I know you're gonna do that.
How?
You're gonna move the 15 over, divide it all by 2, take.
Ah!
No, not divide all of it by 2, but move. No, you can't.
Correct.
Oh, you need to factor out the cotangent.
I can't, can
Is a factor.
we have to
No.
factor.
No. You're a terrible person.
Because then you have cotan squared, cotan squared.
What? What?
I am going to show you guys this nice little trick of called U substitution.
Oh, no.
U substitution is what?
You already showed us.
I know,
I
well,
mean, I
this,
forgot all of them.
well, this is good.
I don't think I ever did very good with the substitution.
U substitution is you're gonna you could use it a lot with this type of stuff because it makes something that looks like crap look somewhat feasible. Okay, so if I rewrite this out, if I let u equal cotangent squared, then I get this: 2u squared minus u minus 15 is 0. And now you're at a regular run-of-the-mill factoring problem. What times what's negative 30 by multiplying your tails, that adds together to get negative 1. 5 and negative 6, very good. So I write that out. I get, excuse me, 2u squared minus 6u plus 5u minus 15 is 0. So I'm turning this into a factor via grouping problem. I'm going to take my GCFs out of both of those, out of the 4 parts. You remember, you group the first 2, group the second 2. If I group the first 2, the 2u squared and the 6u, what do they have in common? So I factor out the 2u, and I have u minus 3. What do I factor out of the second 2? 5. Very good. Are the 2 things within the parentheses the same thing? That's a good sign. SIGN. And then write down the rest. Do I have 2 parts that are equal to 0 now? Yes. So now what did u equal?
Cotangent squared.
Cotangent squared. So what I'm going to do is this. I'm going to rewrite this now as cotangent squared x minus 3 is 0. And 2 times the cotangent squared x plus 5 is 0. What do you do first? Math. Excellent. Within that first step of math, what would that first math step be? Add the 3. Good. What? If I add 3, I get cotangent. And now what do? Square root. So you take the square root, we get the cotangent of x is plus or minus root 3. We okay with that? Which therefore means what angle has a cotangent of plus or minus root 3?
30.
Yes, I'm sorry, I didn't think about that. I was just thinking.
Like, I just have it set off.
Oh. You shouldn't have said that. I would have said, yeah, way to go. So cotangent is the inverse relationship to tangent, which means it's going to be adjacent over opposite. So it's got to be your 30-degree angle. So this is going to be your pi over 6. So we just did one that had pi over 6 in all 4 quadrants. So we knew that a second ago, and that's the other thing that's going to happen. After you do a few of these, what will happen is that as you notice, it's the same answer, whether it's sine, cosine, tangent, cotangent. If the oscillation between the different values are the same, your general solutions are going to be the same. So this one, it's going to be your pi over 6 plus what?
Pi over 6.
It's going to be pi over 6 plus pi n. And the other one would have been, on this one would have been 5 pi over 6 plus pi n. That's how I get all 4 of those answers in terms of general solutions. It's how I'm going to bounce back and forth. Okay.
Why do you have the 5
Pi over 6 is my first positive.
Yeah.
The other positive is at 7 pi over 6. 5 pi over 6 is my first negative. Another pi is the 11 pi over 6.
Oh, okay.
That's how I get between all of my positives and negatives. All right. And now I go back and I solve the same thing for the other possible angle. The other one was what? Subtract 5 divided by 2.
Wait, then why didn't we have to do 2 solutions for the first one that we did? Pi over 6.
We did.
We did?
Yeah. Can I take the square root of a negative?
Nope.
So am I done? You will deal with imaginary trigonometry next year. I'm not lying either.
If it weren't,
Imaginary trigonometry.
if it weren't a negative, how
Oh,
would
yeah, that's what
You'd have to have a calculator. I'm not lying. It's a thing.
It's imaginary, it's not real.
Okay. So yeah, this one you wouldn't
How
have.
about I'm just saying, show us?
No, I actually was helping Alicia out for pre-calc stuff just last hour. Okay. What's the other one here?
No. Go to the lab. I want to see it again. Will you fancy it?
All right, so I have 3 times tangent cubed of x minus 3 is 0. Very good. Everybody okay with the first couple of steps to be add 3, divide by 3?
Yes.
Okay. Now, a lot of times when you're seeing these problems, if you want to skip ahead a little bit, by all means, I have no problem with that. So you have tangent cubed of x is 1. Which means, what do you do now? Cube root. What's the cube root of 1? 1. Is it plus minus? No. So, what angle is going to have the cube root of 1? Which is, so x is inverse tangent. Correct. It's got to be at a 45-degree angle, so it's at a pi over 4. Pi over 4 is in the first quadrant. Where else is tangent positive?
All students
In the third quadrant. So my answer then, if I look at it, it'd be these 2 angles here. And they're, how far apart is pi over 4 and 5 pi over 4? Pi. Is it the same distance to get back to pi over 4? Yeah. So your answer would be pi over 4 plus pi n.
we also do the other one, so like
I don't need to because this one was just a positive one because we took a cube root.
wait, so when it's a cube root, you don't do the plus minus.
Correct.
When it's a 4 though, like
Then you'd have to take plus minus.
so only when it's the odd you don't do the plus minus. Okay.
Yes, ma'am.
So if it's like a full, if it's like a full pi, you just do plus pi over pi n.
2 pi. Oh, you might.
Like
You
you're-
drew a.
if
You drew.
Not
You
a
drew.
full circle. If you do like half, so like 1
Yes.
pi, you just.
Yep. Yeah, and you look at it. Pi over 4, 5 pi over 4 is 4/4 more.
Yeah. It's like if you went a full rotation, then you do pi n.
Yep. Yep. Another weird one. When was it? way to do this. Oh wait, that's not the way. I'm sorry, I wrote down the wrong problem. Oh, you're fine. That was easy. Ah, you're fine. I want to make it simple. Alright, this is about as bad as these things are going to get. I am. Now, in this case here, notice that there is nothing squared. And I can't really combine like terms or anything here. You have to square both sides. So here's what's going to happen. When all else fails, sometimes you have to square both sides because what you're doing, you're still keeping things balanced. So what is junk squared? Junk times junk. Be careful, don't kill a puppy. 1 minus 2 cosine x plus cosine squared x equals. The other side I don't have to FOIL because it's just a number in front of sine of x. If I square it, you get 3 sine squared. 3 sine squared. 3 sine squared. See how they run? See how they run? Which means I need to show you guys a trick. What's the Pythagorean theorem?
A squared plus b squared equals c squared.
Okay.
1 squared plus 2 squared equals 3 squared. Oh
Yeah. Think about it in terms of the unit circle when we first talked about x, y, and r. Our r value was playing the role of the radius, right? And when you did Pythagorean theorem, we were saying that it was x squared plus y squared is r squared. Now, what is the radius of the unit circle always? 1. So if I go back in terms of the unit circle, this radius is always going to equal 1. What was your x value always? Think of the ordered pairs. What's the x value on the unit circle? Cosine. What's your y value? Sine. So this means that in terms of the Pythagorean theorem, it's the cosine squared plus the sine squared always equals 1. That's 1 minus secant squared, but we'll get there.
Wait,
There's trig identities. We'll get to them.
but what about, why is it cosine squared?
What's your x value on the unit circle? Cosine. What's your y value?
Adjacent. Oh, okay.
That's why that works.
Okay.
So what happens here is that we get what's called a trigonometric Pythagorean identity. Scrabble board. You have a trig ID, and we're going to have a bunch of these. We're just going to start with this one. Cosine squared of x plus sine squared of x always equals 1. Which means I can manipulate that equation to get cosine squared by itself or sine squared by itself. If I wanted to get cosine squared by itself, that would say that cosine squared of x would equal 1 minus sine squared, or sine squared is 1 minus cosine squared.
So how does this help?
How does this help the last problem? If you look back at the last problem, we have,
You throw 1 minus cosine squared x.
correct. You're going to do some substitution. Because if you go back to the problem that we have, what was it? Something minus 2 cosine plus a cosine squared. Well, I can take data. I can take this and substitute this.
Oh, great.
Because when you have a sine squared and a cosine squared, you want to put it in terms of the same trig value. The reason that I'm choosing to rewrite everything in terms of cosine is because I've got a cosine squared and a cosine of x. I don't want to put I can't do anything about cosine into a sine, it doesn't do anything. But when I have squared terms, I can rewrite them in terms of each other. So what happens then, I get the following. 1 minus 2 cosine x plus cosine squared equals 3 times 1 minus cosine squared. Oops, forgot my x. I'm just using substitution. This trick of a Pythagorean identity allows me to do that. There are a bunch of Pythagorean identities. We'll have them for cotangent, we'll have them for tangent as well. Not even going to bother getting into any of the equation stuff that has that quite yet. We'll do something like that after we get back from break. It's not a big deal for right now. Okay? Exactly. Now you distribute to 3, and we're going to go back to a factor problem. Can I go back to a single page?
Yeah.
So when I go back to, oops, I needed this. When I go back now, I have 1 minus 2 cosine x plus cosine squared equals 3 minus 3 cosine squared of x. Pick on the little guy again and move everything to one side and set it equal to 0. So I'm going to subtract 3 and add 3 cosine squared. So subtract 3, I'm going to get negative 2 minus 2 cosine x plus 4 cosine squared x is 0.
So we're gonna do factoring again.
Again, yeah. And what I'm going to do first is I'm going to rewrite it into that descending order because it's cleaner.
And then put the u in.
You can. In this, I normally don't do the u substitution when it's just a square term because it's not as crazy looking. But I will do it again if you'd like. It's not a big deal.
No, it's okay. I just wondering.
So if I move this around, we get 4 cosine squared x minus 2 cosine x minus 2 is 0. What is the first rule of factoring?
GCF, don't kill puppies.
GCF. Don't kill puppies either, yes. GCF, what's your GCF here? 2. Since I'm setting it equal to 0, will that 2 have any bearing upon the problem whatsoever? No, so just divide out everything by 2. At this point, you can go ahead and do what we were doing earlier, that u substitution, by writing it as 2u squared minus u minus 1. Or since it's just a squared term, treat it as like you would normal factoring. What times what's negative 2, you add together to get negative 1. Negative 2 and 1. So if I wrote it out with the cosines, I'm going to get 2 cosine squared x minus 2 cosine x plus 1 cosine x minus 1 is 0. I just did that split middle term, multiply my tails to get to the middle, and then I go back and I do GCFs twice.
So would you take out the cosine x and then be cosine x minus 1?
Here I would take out the 2 cosine x.
Yeah.
Yeah, yes.
Okay.
Yep, exactly. 2 cosine x. And I have a cosine x minus 1. And over here you have just a 1. And as you can see then, you're going to get 2 terms. You'll have a cosine x minus 1 equals 0 and a 2 cosine x plus 1 equals 0. You okay with that? First equation, subtract 1, divide by 2. What angle has a cosine value of negative 1/2? Well, where is cosine negative? Cosine's negative also in 2 and 3. So it's my 60 degree. Bless you. Here and here. Coming over to this spot there is going to be, if it's up 60, so it'll be 2/3. And then this is 1/3 past, so it'll be 4/3. And now I want to think about it in terms of general solution. Is the difference between 2/3 to 4/3 the same as getting from 4/3 back to 2/3? No. These two do not have the same differences between as you're spinning around the circle.
This would be 3/4 pi and 1/4 pi.
No, you just write them, because if you did 3/4 pi, then you'd wind up here, and then you'd have to wind up here. You're going to hit all these spots. Exactly, very good. In order to get from here back to here, you have to go all the way around. That's why you're adding 2 pi.
Oh, so
Oh,
two
so it can't
different
be
ones,
quadratic.
right?
Correct.
Yeah, so you'll have two different like general solutions.
Yep.
Is that just what you do if you don't have a constant?
Correct. Yep, and that's the one style I haven't gotten to show you guys yet. Okay. Same idea with the cosine of x minus 1 equals 0. That one's pretty quick because it's going to be what angle has a cosine value of 1? Zero. Cosine is 1 at 0. And how long does it take you to get back to 0? So it'll be 0. Where do you start though?
Oh, yeah, you could just assume it's 0.
I don't want to angle side side out of you and me. ASS. Okay. Like I said, that's about as goofy as this stuff's gonna get. Okay? Yeah. I want you guys to do general solutions. Oh, okay.
I was done in like 15 minutes. Oh my god.
If I'm not mistaken, I think there are.
Are all of them general solutions?
Yeah, these are all general solutions. I know the book says to do them within one revolution. The ones you guys did last week were supposed to be general solutions, but I thought that doing those on a Friday, it was easier to do list everything, which it appears as though it was kind of the right decision, instead of trying to get you guys to do general solutions first. So I want you guys to do the general solutions of these. We'll build more into this because they can get kind of goofy. Yes, ma'am.
So do you want to scatter first or double?
I would try and get as much as you can. I would like you guys to try and be able to still quiz by the end of the week. All right? Because these guys are quizzing Thursday. If you guys got to do it Friday, I figure that way you don't have to wait another week to come back. You know what I mean? I think that works out well, right? Except for you.
I was gonna try to do it. I was gonna try to do all my work for math last night.
So it's 6
And then I looked at it was like 6, which is like
Midnight.
on the clock a little bit.
Yeah.
And I'm like, yeah.
Take you a little time to get through that jet lag.
Jet lag is fun, especially when you're on a first flight. It's not fun. That's having to be way too many times.
Yeah, I told you guys I went to Italy and it was awful.
I went to Qatar though to visit my uncle and like the time changes.
That'd be a fun trip though.